Hi, Mr. Richards here. Today's grade 6, Unit 1, Lesson 8 practice problem review is on area of triangles. Let's use what we know about parallelograms to find the area of triangles. In problem 1, to find the area of this right triangle, Diego and Jada used different strategies. Diego drew a line through the midpoints of the two longer sides, which decomposes the triangle into a trapezoid and a smaller triangle. He then arranged the two shapes into a parallelogram. Jada made a copy of the triangle, rotated it, and lined it up against one side of the original triangle so that the two triangles make a parallelogram. 1. Explain how Diego might use his parallelogram to find the area of the triangle. And in 2, explain how Jada might use her parallelogram to find the area of the triangle. Well, since Diego just decomposed and then created a parallelogram, he could simply, with a base of 3 and a height of 4, he could take the area equals base times height, do 3 times 4, and get 12 square feet. And since it's simply, as we go back up here, your base of 3 and your height of 4, he took the triangle, made a parallelogram out of it, and that works. Now, Jada could use a parallelogram again, but this time she has a base of 3 and a height of 8. And so when she takes 3 times 8, she gets 24. But here's the thing. That was 2 triangles worth. So she needs to take 24 and divide by 2 to get the 12 square feet. And of course, she could also do 24 times 1/2 as well to get that 12 square feet. Now, in problem 2, find the area of the triangle, explain or show your reasoning. Well, the method I like to use quite often, personally, is just to make these into parallelograms. So if I bring this side back out and down, I now have 2 identical triangles. 1, 2. Then, my base and my height have to meet at a right angle. And so if I consider this side my base on the bottom, 1, 2, 3, 4, 5, 6 is the length of my base. And then my height here would have a 1, 2, 3, 4. Now, areas for parallelograms are equal to base times height. So 6 times 4 is equal to 24 square units. But I have 2 identical triangles doing this. So I either need to do 24 divided by 2 or 24 times 1/2. Either way, I get 12 square units. Now, what about B? It's on a nice fun slant here, isn't it? And so what I'm going to do is try to draw a straight side in. Now, that straight side length on the bottom here is 1, 2, 3, 4 long. So I need to draw something that's 4 units long here. And so 1, 2, 3, 4 units long. And then I'm going to connect this like so. And now I have my 2 identical triangles. 1, 2. And the other way you can double check that is I'm going to draw my height in right now. I'm going to go straight up from this base. And so my height is going to be 3. And my base is going to be 1, 2, 3, 4. Now, how I can check this, when I went straight up here, from this bottom right corner straight up, I'm 1, 2, 3 to my slant here. Well, if I go straight up here, I'm 1, 2, 3 away from this slant. So it matches. That means this and this are parallel. Now to find the area of this parallelogram, area equals base times height, which is 4 times 3, which is 12. But of course, to find the one triangle, I need to either do 12 divided by 2, since there were two identical triangles, or 12 times 1/2. Both solutions get you 6 square units as your answer. Let's move on to problem 3. Which of these triangles has the greatest area? Show your reasoning. If you get stuck, try using what you know about the area of parallelograms. Well, I'm going to take this opportunity to find the area of all three of these. So if I bring this straight up, and I have my right angle, I have a base 1, 2, 3, 4, 5, and a height 1, 2, 3, 4. Area is equal to base times height for a parallelogram, which is going to get me 5 times 4, which is 20. That's the whole parallelogram. We either need to divide by 2 or multiply by 1/2, and we'll get 10 square units as part of A. We look at B. I'm going to call this side here my base, and it has a length of 4. So I need to come down 4 units to right about there, and then draw this in the best we can so we can have those two parallel sides. So my base is going to be 4. My height connects these at a right angle, which is 1, 2, 3, 4, 5 for my height. And again, as we double check these, you can make sure that it's parallel. If I take this base straight up, it's 2 over. If I take this base straight up, it's 2 down as well. Now, to find this area, area is equal to base times height for the parallelogram, which is equal to 4 times 5, which is equal to 20. Well, I have two identical triangles, so once again, 20 divided by 2, or 20 times 1/2, will get me a solution of 10 square units. So far, A was 10 square units and B is 10 square units. What about C? Well, in C, again, I have a vertical base here. And so what I'll do is say this is going to be one of my bases. It's a length of 4. And so I'm going to come 4 down. 1, 2, 3, 4. And then connect these. So my base was equal to 4. My height needs to come up at a right angle here. And my height is equal to 1, 2, 3, 4, 5. Feels like deja vu all over again, huh? And again, to double check to make sure that we have these parallel, if I go straight up from the base, I'm 1 down. Straight up from the base, I'm 1 down. So this line and this line are parallel. Area for the parallelogram is equal to base times height. Area is equal to 4 times 5. Area is equal to 20 for the parallelogram, but the two identical triangles, so either 20 divided by 2 or 20 times 1/2 for a third time gets us 10 square units. So what does this mean? Back to the question again. It asks us which of these three triangles has the greatest area. Show your reasoning. If you get stuck, try using what you know about the area of parallelograms. Well, which of these three have the largest area? They're all the same. All have an area of 10 square units. That's supposed to be a square units there. There we go, with a period. All right. As we move on to question 4, draw an identical copy of each triangle such that the two copies together form a parallelogram. If you get stuck, consider using tracing paper. Let's bring it on in on D. And we'll use this method that we've been practicing here. This has a base of 4. And so what I'd like to do is come out in either direction, really, but I'm going to go to the left to have more room. 1, 2, 3, 4. And then I can connect these down. And now I have a parallelogram where I have a base of 4 and a height of 3. It's not asking us to find the area, so we'll move on to the next one. E. Now, E's a little tricky, isn't it? Because it's on this angle here, and I do not have either a vertical side that's straight on the grid or a horizontal side that's straight on the grid. So what can we do? What can we do? I'm going to look here at a point here and a point here. And I'm going to call this side my base. Now, why would I do that? Notice, this is pretty much going from this point 2 down and 1 to the right. And so what I could do is start here at the base, or at the bottom here, and go 2 up, and then 1 to the left, which puts me right there. And if I draw in this parallelogram, or I'm sorry, these 2 sides, I will form now a parallelogram using 2 identical triangles. And that's doing it without tracing paper, which isn't always the easiest thing in the world to do. And then as we look at F, what we have here, I see a base on the bottom here. And so here is my base. I want to make a matching side that's 4 long. And so I'm going to come 1, 2, 3, 4 down and connect these 2. And that will give me my 2 triangles that form the parallelogram. And again, to check this, I'm 3 out and 1 down, height of 3, 1 down. And so that would be 3 possible solutions here for these parallelograms. Problem 5, a little bit of review here. 1, a parallelogram has a base of 3.5 units and a corresponding height of 2 units. What is its area? We can find area by taking base times height. And so our base is 3.5. Our height is 2. And so we have an area of 7 square units. In question 2, a parallelogram has a base of 3 units and an area of 1 8/10 square units. What is the corresponding height for that base? Well, if I have an area of 1 8/10, that's going to equal our base of 3 times our height. What I can do here to finish this is to actually take our 1 8/10 and divide it by 3 to get that height. When I take 1 8/10 and divide it by 3, I get 6/10 units for that height. And lastly, a parallelogram has an area of 20 4/10 square units. If the height that corresponds to a base is 4 units, what is that base? Well, we have 20 4/10 units for our area. Our height is 4 units. I'm sorry, our base is, we don't know, and our height is 4 units. And so, if we were to take 20 4/10 and divide it by 4, that would get me my base, which is 5 1/10 units for that base. And that is it for this grade 6, Unit 1, Lesson 8, Practice Problems Review. Good luck.